While the Expedition 40 crew members continue to work throughout their busy workdays there aboard the space station, we'll take some time to look at another vehicle. NASA's getting ready to launch its new human spacecraft, Orion, into space for the first time in December. Getting Orion into space is only a part of the mission. Just as important is getting Orion safely home. Orion will travel 3,600 miles into space before re-entering the Earth's atmosphere and splashing down into the Pacific Ocean, where a team of NASA and U.S. Navy technicians and engineers will be waiting to retrieve it. Some of the members of that team were here at the Johnson Space Center just last week testing out techniques for the retrieval, and my colleague Brandi Dean went out to the Neutral Buoyancy Lab to talk to them. We'll listen to this now.
This is Tim Goddard. He's the dive manager here at the Neutral Buoyancy Laboratory, and he's going to tell us a little bit about the recovery plans for Orion. Thanks for joining us, Tim.
You're welcome. So since the last time you guys came out to visit, we've been to sea. During that evolution of at-sea trials, we experienced rougher than expected sea conditions inside the well deck. Outside the well deck, it was a sea state 1, nice, calm, glass sea.
We should probably, pause and describe what the well deck is.
Okay. So we are doing a well deck recovery that's on an LPD class amphibious ship. The well deck is the submersible area where they bring in LCACs, the air cushion vehicles or the landing craft. They'll bring them in and out of the vessel. The well deck can go up to about 8 or 9 or 10 feet. So we're going to do the same thing. We're bringing the capsule inside of that while it's submerged. We're controlling it by tending the whole time, and then we'll deballast, bring the well deck up and set it down inside of a cradle. What we realized, what the Navy didn't know and we didn't know, was even in a calm sea state, if we have the right wave period, the wave starts pitching, the ship starts pitching, and that becomes a chaotic effect inside the well deck.
Okay.
So everything that you're going to see today is to mitigate out all of the loads that were greater than expected the last series.
Okay, and you've got a couple of different things you're trying for that, right? What are they?
What you see back here is a slick capsule right now. We're going to go right into Plan B, or lifting exercise. In the event that we cannot do a well deck recovery, we're going to use different classes of ships to use a knuckle boom crane to come over and just do a standard lift at sea. So we'll pick the cradle up, we'll put the capsule up, get it over some point of the ship, and then set it down in its cradle, all in a dry environment.
Okay.
But to do that, it requires the divers to go out in small boats, attach a bunch of different lines, and get them all ran the right way before they bring it up, before the ship comes along the side, and then finally the ship will drop its crane down, which we're going to simulate with our overhead crane. And then they'll hook up, divers will back up, and they'll pick it up and then set it down in the ship.
Okay, so this is Plan B. If we're not able to bring it into the well deck like we talked about, this is another option.
This is another option.
That I guess we're going to try out, at the end of the month on our next recovery test in the ocean off the coast of California.
That's correct. Starting at the beginning of August or the end of July, we're going to be out in San Diego again. We're going to be on the leeward side of San Clemente or one of the other Catalina Island out there. It's in a protected area. We can get the sea state we want, and we can try the well deck recovery options again. What we're going to do later, which you can't really see here, but I have a horse collar system. What that allows us to do is spread the load path out on tending and towing and handling the capsule in general. What it does, last time we had some point loading that we were breaking some straps, which were designed to fail, but the greater than expected load, we're mitigating that by spreading that load path all the way around the circumference of the capsule itself.
Okay. Well, so you've been practicing for a little while, I think kind of on and off this week, and how is it going so far?
We made a lot of progress on Tuesday and yesterday. We went back to the drawing boards and made a lot of engineering changes, and then we're back doing final changes before we go out to San Diego for the test run next month. We also had the Navy divers in the facility about a month ago looking at this from what they saw of our initial designs, which we came up with at KSC at a group meeting. That was our version 1. This is version 2.0 on all of our hardware.
Okay. Well, so you think we're ready to go back out to the ocean?
I think we're ready. The Navy has bought off on what we're doing. We made a lot of good changes. We're going to tweak some final stuff in the next couple days. We're going to take it out to San Diego and do some fit check next week in a dry environment. They're all supporting Operation REMPAC in San Diego right now. The ship will come in, then the divers will come in. We'll do a group meeting, run through it all on a dry dive again, and then finally go out to sea and practice it one more time.
All right. Well, I think we'll look forward to hearing about that test in just a few weeks. Thanks so much for joining us.